Hey, so it's about time. So let's get started. Um, a quick introduction about myself. I am Kishore Boyalakuntla, Vice President of Products and Marketing Applications here at RIZE. Few months ago, prior to joining RIZE, I was VP of Product Management at SolidWorks, and for the last 2.5 months, been at RIZE. Fantastic, amazing products. So I'm excited to give you some introduction to what we do here at RIZE. Very quickly, um, at RISE, the founding team focused on the user as much as the 3D printing process itself. And I will take you through what that is in terms of ease of use, the precision, the execution, and such. So I was told that I have to give you a primer on jigs and fixtures. I'm sure some of you already know a lot of what I'm going to talk about. For the first 2-3 minutes, please bear with me. Pressure, and then we'll talk about case studies and how the RISE printer works, and we go from there. So, all manufacturing processes require manipulation and positioning of parts, whether you're trying to weld the assembly or put the assembly together, wiring, harnessing, or any number of things. And in some cases, two hands are not enough. We all experience that. And sometimes the manipulation is too precise or rigorous to be accomplished by hand. And sometimes whoever is doing this is not an expert, so they need some additional tools to locate and position the components. And so with jigs and fixtures, you can increase the speed, precision, ease of manufacturing processes, and obviously time to manufacture. Jigs and fixtures are some of those strategies to make it happen. Now, what's unique about jigs and fixtures is sometimes as parts change, as manufacturing strategies change, sometimes for small volumes, sometimes for big volumes, you will have to create and design custom jigs and fixtures. Sometimes going from one iteration of a product to another requires you to create certain jigs and fixtures. And 3D printing, and especially RISE, gives you this amazing speed and flexibility to create these and start moving towards production. Now, a very quick update what a fixture and what a jig is. Basically, a fixture is a component that's been fastened into play and placed on a rigid surface, like what you're seeing here. And basically, it may be used to hold workpieces in place securely. Sometimes alignment needs to be done. Sometimes alignment needs to happen, and it's typically done with hand or with some tooling. A jig, in the other hand, it holds the workplaces securely, but it may or may not be fastened in place. They are used to guide tooling with respect to the workpiece or guide the workpiece with respect to the tooling. And I have seen customers that is producing custom jigs and tools can be very expensive with long lead times when you go out for custom manufacturing, and 3D printing is perfect for that. Very quickly you can create those and go from there. So when we take a look at, so that's a quick primer. Obviously with jigs and fixtures you can do things like clamping, you can do work holding, whether you're machining the part. You can create brackets, cutting and drilling guides and templates, and assembly alignment guides. And all these are actually done by our customers today quite successfully. Um, and one of the things you must notice here is this marking capability. So you see that one of the things about RISE is not only does it build very strong parts, our core technology allows us to jet functional inks. And what this allows you to do is actually put part numbers, like you see here. It allows you to put QR codes that actually, when you QR scan it, can tell you assembly instructions. And so a lot of times, as you produce parts over time, you want to make sure you know precisely what this work holding is for, or what this jig was for, or what this fixture was for. And with RIZE, our customers take full advantage of it. They put the part numbers and everything, and sometimes the design changes are minor, and you want to make sure you capture those accurately. So you can actually have the digital thread from your CAD design all the way to manufacturing, and you can go back and locate it with your PLM system 5-10 years down the road. One of the advantages of RIZE, and this is what our customers tell us, and I will show you some case studies, is that it's fast, the fast rate of production. And when we say production, it means both pre-processing, which is getting the part ready for manufacturing, manufacturing it on RIZE, and then post-processing, which is getting the part ready for use. It is the fastest in terms of in the marketplace as well. So you can do clamps, work holding brackets, cutting and drilling guides, templates, and all these different components, and our customers are doing those with RIZE today. So why RIZE? RIZE 1, which is a printer name, and why is that the right fit? Number one, material strength. The material, we call it internally Rizium, and Rizium is a very high-end engineering compound, and I will talk more about that. It's extremely fast and easy to go from your CAD design, whether it is SolidWorks or Creo or Inventor or whatever that might be, to very quickly going to manufacturing. And also with marking ink, you can actually do alignment, basically dimensions and instructions of use. I have seen customers that put a sign here is a, put here to the left and add this much amount of torque and things like that. So these are some things that we see, and you can see the complexity of this particular part here and the precision of the component as well. So here's an example of something we built here. It's a multi-tool hand press fixture, and we built this inside RIZE as a two-part component. You actually locate in place, screw this in place, and obviously with QR codes and everything else, you can track. Or you have to add some strength to this. Obviously, it's a bottle opener, so you might want to insert a metal plate to increase strength of the hook, custom fixture to secure the hand press and such, to do those things. So these are some of the use cases we see our customers do. So why Rizium? It's, as I said, it's a high-end engineering compound. It's a functional strength test is what you are seeing right now. Here is the clamping force, and you can see all the different kinds of clamping forces on this particular part that this third party tested. And here are examples of ABS, onyx, machine nylon. This is Rizium 1, which is RIZE 1 from RIZE, nylon with carbon fiber, nylon and PC ABS. And you can see that that in this particular test that this third party did, the part was able to actually pass up to 220 pounds of clamping force, whereas you can see the failure of different materials at different strengths. So what you get with RIZE is a material that's very strong, where you can actually create jigs, fixtures, work holdings, and such. So a quick introduction about Rizium. As I said, if you see the material scale, it's almost 1.5 to 2 times stronger than ABS, stronger than polycarbonate. This is where the Rizium sits. It's an amorphous material. So when you actually print the part, it's a heated chamber. It's a fully controlled heated chamber. It's amorphous, so it flows very well. So with Rizium, you get some very good Z strength as well. It's not just in X and Y. The ingredients that make Rizium 1 are actually USP Class 6 certified. So they are actually approved for skin and food contact. It's all-weather usage. The material has very negligible moisture absorption uptake. So in other words, you can have a material in the box, like all plastics, until you print. You don't want to expose it to outside, but you just keep in the cardboard box as is. And then when you actually print, and after the part is printed, what you will see is that even after a few months, there is no warping, no change in material properties, because it has very negligible moisture absorption intake. It's a clean material. In other words, when you actually put it next to your office, there are no volatile organic compounds that come as a result of printing with Rhizium. So if you go back to this slide, whether it is ABS or onyx or nylon with carbon fiber or PCABS, you don't see it, but every time you print a part, you are actually getting volatile organic compounds. And in fact, it is actually compared in some research literature. It's like smoking a few cigarettes when you print all day next to you. With RIZE, because of the material property, there are absolutely no VOCs, and that's why US Navy is actually putting this printer in a submarine, because it's completely safe, people safe, and skin safe material. Very low linear expansion coefficient, very low volume resistivity, good for semiconductor applications if you have some electricity that's moving through. It has a good dielectric constant, and it has obviously a specific gravity of 1.01. So that's how Rhizium works. I actually want to play a video, and sometimes on GoToMeeting, the video doesn't come across very well, so I'll be pausing it and explaining it to you as to how the whole process works. So here's SolidWorks. Obviously, I was with SolidWorks for many years. It's one of my babies. So here we have a part that's designed in SolidWorks that's going to RIZE Slicer software. The software is actually installed on the local computer. So basically, once you click from SolidWorks, you see the part come into the RIZE software. Okay, let me play it. Once it's there, it's very easy to add marking capabilities. So let's just position it. You can see the ease of use. And to add a logo or a part number, it's very simple. You just get an image and you locate it and you keep it anywhere on the model. So that's it. And it conforms to the geometry. So you put the geometry in the normal position and you get the logo. And at that point, now once you position it, it's there. And when we print it, we actually print it at the voxel level. And this particular thing goes deep into the part, so it cannot be scratched away or anything like that. Now, adding a QR code that brings metadata from your PLM system is pretty straightforward as well. So here is the data that comes from whether you have a PLM or ERP. It could be manufacturing instructions. It could be any number of things. And once you bring in, there are some QR code generators. You just pull that and you position that QR code right there. And that's it. And now you are ready to print. So that's how simple and straightforward it is. The supports are automatically generated. I have never seen a customer manipulate supports at all. It's ready to go. And so with few clicks, once you have the geometry or STL, you can put your logos, you can put your part numbers, and you go to the 3D printer. What you're seeing here is RIZE 1. As I said, this is completely heated chamber. On the left, you have two spools, 820 grams each, with hot swap capabilities. So as you print, if one spool is over, the other one will take over and run with it. So it's a very easy to use touch here, very intuitive. So that's how you put the bill plate. It's magnetic. You just slide it in. You never have to balance it because they're auto balancing inside the product, and it automatically tells you how much material is there. Let me just go back a little bit right there. So you know how much filament is there, filament spool 1, filament spool 2, the release ink and marking ink. And once that is done, what you do is you go to the library, select the part that you want to print. It actually tells you how much time it takes, the number of layers, the layer thicknesses, and at that point you hit print, and that's pretty much it. So this is why we believe going from a geometry pre-processing to processing, it's the fastest and the easiest with very few clicks. Now it is auto leveling. You never level the bed. You don't have to put glue. You don't have to put anything else. You see that it's leveling at 6 different points. And once the leveling is done, it's ready to print. Okay, it puts the rafter at the bottom and the rafter sticks to the base, and you start building the model and going from there. So literally with few clicks, you can actually go from design to 3D printing. And that's why we have CNC users that have put this machine on the manufacturing floor. As they are cutting metal on a CNC, they are actually using the additive manufacturing to create work holdings, jigs, fixtures, and everything else from there. Engineering teams, engineering managers, everybody are doing exactly the same thing. So once the part is done, it's a very, you open the thing, that the part slides out. Obviously, you scrape it off the base. And removing supports. And this is another one, which is a key innovation. And this is what we mean by time to part. The technology, what it does, in between the supports and the model, it actually puts release ink. So you literally peel the supports off. And that's why you can take some very complex geometries, build it on RIZE, and you can, with a plier or with your hand, very quickly remove those supports, and you're in business. So the time it takes from a printed part to a part in hand, we believe this is the fastest in the industry. See how it comes off? It's that simple. There are some additional supports. You just pull it off. That's that. 2 and 3, and that's the last piece with the plier. You take those two things out and you're done. There are a few things here. Number one, when you remove supports, no additional processing is necessary. You get perfect surface finish. There are no residues. There are no surface imperfections. So this is a pipe clamp that you are seeing here, and it's ready to go. And lastly, I will show you the QR code. You just take the QR code, take your cell phone, let's say a year from now, 2 years from now, or somebody who's assembling it, you just take it there, click on it, and there is all the part information that's ready to go. That's pretty much how it works. Few clicks from design to 3D print. And once the printing is done, very quickly remove the supports and you have a part in hand. And that's why our customers and our resellers tell us, with RIZE, you have the fastest design to part, and it's the lowest cost of ownership. So let's talk about industries and applications. We have many customers in life sciences, in manufacturing, in aerospace defense, for preclinical applications in life sciences, prototyping, custom tooling. One of the things that life sciences industry likes about RIZE and Rizium very much is it has very low chemical reactivity, and it is safe for skin and food touch. So they are compounding materials with nozzles and things like that. With marking and traceability, because sometimes you can take some minute design changes and you will be able to trace it precisely which functional prototype is for what. On manufacturing, we already talked about custom tooling, functional prototyping, and end using parts with digital traceability, and obviously in aerospace and defense, because of high strength, the ability for this printer to work in extreme conditions and full digital traceability are some of the key advantages of the RIZE printer. And we talked about making easy, and this is truly what our customers tell us. There are no walls to jump between the model and print, and very little effort to go from print to part. So our customers tell us sometimes they get 50% faster than other 3D printers in-house, and 1/3 of the cost, because the labor cost once the part is printed is very little or nothing. Also, the material is one of the lowest in cost in the industry. In fact, for the inch cube or the weight, it's very low price. So our customers tell us, compared to other 3D printers, it's the fastest to part, and it's the lowest in terms of per part cost. The last thing, one of the things I want to share with you is not only did the team, engineering team and RIZE focus on the user, also focused on safety. I talked to you about zero VOCs, zero volatile organic compounds, things like styrene and everything else that comes out. In fact, RIZE is one of those printer where you can take it on a factory floor without having to pass any safety regulations because of zero VOCs, and we have customers that love it just for that. Taking it to a factory floor, you don't have to go through onerous safety and all the forms that you need to pull in. Obviously, no chemicals, no glues. It's a medical grade polymer. It's very strong. branding and QR code for authenticity and traceability. I want to talk about a customer of ours, New Hudson Facades. Every building needs custom facades. And here is Andy Black, the engineering manager. I put RIZE one next to my desk so I can use it all the time. It's so easy, anyone can use it. And in fact, they have CNC programmers, engineers, and managers, all of them using RIZE to 3D print parts. Here are some examples of the RIZE part. This is a work holding to actually position this for assembly. You can see the precision of the component right there. Here are some parts that are going into production. And what they are telling us is RIZE has a less than 3-month ROI. They are seeing a $200,000 in savings with RIZE. They have other 3D printers in-house. All of them are sitting idle now or close to idle. Everyone wants to go to RIZE because of the simplicity, ease of use, and they're confident that the part will get done. Because of that, their inspection frequency has gone up quite a bit, which means their quality assurance has gone up, and 15% increase in production speed, all translating to $200,000 plus in return of investment. So we never expected, in fact, that AEC would be using RIZE, but we were surprised to find out for work holding, fixtures, gauges, functional parts for production. Additional benefits they see is safety and ease of use. People come to RIZE and they're surprised. They're walking around. We have 25, 30 printers running all the time. There's no smell. It just feels normal, and we haven't vented or anything because of zero VOCs inside the company. It runs 24/7. It's an industrial 3D printer made to run continuously for 3+ years. And they're averaging 2+ parts per day. These are very intricate parts, and that's what they're doing. And in fact, if you go to their bins, you will have several bins of 3D printed parts that they're using for manufacturing purposes. So going back to jigs and fixtures, used to improve accuracy, repeatability, efficiency for high strength, speed, and marking annotations with RIZE, designed for strength and support repeatability and range of applications, and the flexibility, the accuracy, and safety that the RIZE brings to bear. It's truly, we believe, in our minds at least, one of the only desktop industrial 3D printing platform. It is desktop because of simplicity. Anyone in your company should be able to use it to get the job done. We have customers, in 20 minutes after they get the printer, they're actually 3D printing parts. And many of them are not experts at all. Speed, because of one-touch experience for pre and post processing, how quickly you can remove supports and have the part ready. It's fast and safe, no chemicals, no outgassing. And it's industrial because of strength in all directions, industrial nature of the printer, diversity of the applications, and operation in all weather conditions. It's multi-material capability. I didn't even talk about that today. It's digitally connected to Industry 4.0 technologies because the printer, it can be networked, connected to Industry 4.0 infrastructure, as well as the parts conform to Industry 4.0 in terms of traceability, identification, and such. And obviously, we have some partnerships with some very key Industry 4.0 players. So that's what I wanted to share today. You can go to rize3d.com. There's a wealth of information there. Please take a look at it. You can always reach out to us if you have any questions, and we go from there. And I will be available for the next few minutes if there are any questions on the web. Otherwise, thank you very much for joining us.